All right, let's talk about something we see every day but maybe don't really get: magnetism. Sure, you've got magnets on your fridge, but what is that pull? What's actually happening in that invisible space? Well, we're going to look at two totally different ways to explain this unseen force. And trust me, one of these is going to make you rethink everything you learned in school.
So remember back in science class, magnets seemed so simple, right? You had a north pole, you had a south pole. Opposites attract, likes repel. End of story. But what if that's not just an oversimplification? What if it's, well, kind of wrong? What if there's a much deeper story going on?
So on the one hand, you've got that classic textbook magnet we all know. But today, we're putting it up against two heavy hitters. First up, we've got the electromagnetic field theory. I mean, this is the very bedrock of modern physics. And in the other corner, something totally different, a metaphysical model called the plane of inertia. Let's dive in and see what these are all about.
All right, first up, let's travel back in time a bit. We're talking about a 19th century idea that, and I'm not exaggerating, completely changed the world. So picture this. It's 1864, and this brilliant physicist, James Clerk Maxwell, comes along with this mind-blowing idea. He says, hey, what if magnetism isn't some spooky force that jumps across empty space? What if the space itself is doing the work? He proposed that there's a field all around an object, and that field is what holds and carries the energy. And you know what's really cool? It's why he went down this rabbit hole. The whole idea of action at a distance, one thing affecting another with absolutely nothing in between, it didn't sit right with him. It felt like magic, not physics. He was obsessed with finding a real physical mechanism for how these forces actually travel.
So he laid it out step by logical step. First, action at a distance just doesn't make sense. So second, there must be something in the space, a medium, that carries the force. Third, this medium probably carries energy in the form of waves. Okay, makes sense so far. But then came the absolute bombshell. He did the math to figure out how fast these waves would travel, and the number he got was the speed of light. Exactly.
I mean, can you just imagine that moment? Suddenly, it all clicked into place. Light, electricity, magnetism, these weren't three different things. No way. They were all just faces of the exact same thing, the electromagnetic field. This was a game changer, one of the biggest holy cow moments in the entire history of science. And look, this isn't just some dusty old theory. This idea is the reason your phone works. It's why you can listen to the radio, watch TV, or even browse the internet. Pretty much everything we think of as modern technology is built on this one beautiful idea. It's not just a theory, it's the engine of our world.
So, that's it, right? Problem solved. Maxwell figured it all out. Science moves on. Or does it? What if there's a completely different way to look at this? A view that doesn't just add a detail or two, but throws out the whole rulebook we've just learned.
Okay, buckle up, because we're about to take a sharp turn. We're going to explore a totally different model now. This one comes from a more, let's say, metaphysical point of view. And its very first move? It says that the North and South Pole, they don't actually exist. Yeah, you heard me right. No poles. And the argument is actually kind of clever. If you snap a bar magnet in half, you don't end up with one north piece and one south piece, do you? Nope. You get two new, smaller magnets, each with its own north and south. So this theory says, see, it's not about poles. Instead, it says polarity is something it calls the inverse to counter space. I know. That sounds like a serious mouthful. So let's unpack what that actually means.
The heart of this whole idea is something called the plane of inertia. The best way to picture it is like the dead calm center of a massive storm, the eye of the hurricane. It's this perfect point of balance, a sliver of zero pressure, caught in a cosmic tug-of-war between two forces. One that's constantly pushing everything out, centrifugal divergence, and another one that's constantly pulling everything in, centripetal convergence.
So according to this model, the universe is basically defined by two shapes. The first one is a torus, a donut. This shape represents that outward push, that centrifugal divergence. It's the force that creates what we call space and what we feel as a magnetic field.
And if you have an outward force, you've got to have an inward one, right? So the second shape is a hyperboloid. Think of an hourglass. This is the mirror image, representing that inward pull, the centripetal convergence. This creates what the theory calls counter space. And a magnet? Well, in this view, a magnet is just the spot where the donut and the hourglass meet, where these two opposing forces find their perfect intersection.
Okay, So let's just pause and put these two ideas right next to each other. On one side, you have a cornerstone of modern science. On the other, this really wild metaphysical concept. How on earth do these two stack up?
I mean, they couldn't be more different. Maxwell says the force comes from an electromagnetic field. The other model says it's from pressure mediation. Maxwell gives us north and south poles. The other gives us a plane of inertia. One talks about the ether or space-time. The other talks about dielectric counterspace. But maybe the biggest difference? Maxwell's world is built on cold, hard math. The other is built on geometry and intuition. They're not even speaking the same language.
So this all leads to a much bigger, much deeper question, right? When you have two completely different stories trying to explain the exact same phenomenon, how do you choose? What even makes a model good, or useful, or true?
What we really have here are two totally different ways of knowing something. The scientific model, Maxwell's model, is all about prediction and verification. You write an equation, you test it, and if it works, you use it. And the proof is in the pudding, right? It gave us our entire technological world. But the metaphysical model, it's not playing that game. It's not trying to build you a new iPhone. It's aiming for something bigger. It's trying to explain the why behind everything, the very source of life itself.
So, at the end of the day, that's what we're left with. Two maps for the same reality. One map is mathematical, it's predictable, and it literally built the world you're living in right now. The other map is intuitive, it's geometric, and it claims to show you the very blueprint of existence. The question is no longer just how does a magnet work? The real question is, which map do you trust? Which one will you choose to follow?